Aussian sunspot may be about to erupt, sending out the most powerful form of solar flares growing for days. Sunspot Arkansas, 3089, which is facing towards the Earth, has now developed a Delta-class magnetic field, meaning that it has built up enough energy that it may release X-class solar flares. According to National Oceanic and Atmospheric Administration, NOAA, there is around a 5% chance that the sunspot will release an X-class flare. If it does, the flare may trigger a powerful geomagnetic storm in the Earth's atmosphere, possibly resulting in damage to infrastructure and electromagnetic communication systems. Sunspots are darker areas on the sun's surface where coronal magnetic fields are particularly strong. When these strong magnetic fields realign themselves, this can eject solar flares, which are spurts of electromagnetic radiation, as well as giant plumes of solar plasma known as coronal mass ejections, CMEs. According to SpatchyWeatherLive.com, Delta-class fields are usually associated with higher levels of solar activity, due to causing very big sunspots with a reversed magnetic polarity. Solar flares ejected from sunspots are classified based on how powerful the X-rays are: C-class, M-class and X-class. C-class flares are common and have few noticeable effects on Earth. M-class flares are medium intensity and may cause minor geomagnetic storms, while X-class flares are the most powerful, but least frequent. X-class flares are 10 times more powerful than M-class, and an X10 flare is in turn 10 times more powerful than and 10 times more powerful than N. While the chances of an X-class flare occurring from Sunspot Arkansas, 3089 is low, if one were to occur, the resulting geomagnetic storms could have damaging effects on the Earth. According to NASA, X-class flares hitting Earth may result in damage to satellites, global transmission problems, worldwide radio blackouts, and potentially give airline passengers near the North and South Poles small radiation doses. GPS radio signals must pass through the Earth's ionosphere between the Earth receiver and the satellite in orbit, meaning that when a geomagnetic storm is in effect and the ionosphere is disturbed, the radio signal is distorted and the receivers cannot accurately get a position. The largest and most powerful X-class flare to hit the Earth is thought to have caused the 1859 Carrington event, which resulted in bright aurorae being seen around the world, and caused sparking and even fires in some telegraph stations. It's thought that if a storm of this magnitude occurred today, it would result in extended outages of the electrical power grid. The sun's activity follows 11-year cycles, with its sunspot activity levels and subsequent number of solar flares and CMEs increasing as it approaches the solar maximum. The last solar minimum was in December 2019, and the next solar maximum is forecasted for 2025. However, the sun's activity is higher than previously predicted for its cycle stage. Solar Cycle 25. The current cycle is the 25th cycle that has occurred since we began recording sunspot activity in 1755, is on track to outperform Solar Cycle 24. Solar Cycle 24 was an average cycle in terms of sunspot activity, meaning that more frequent and more powerful solar flares and CMEs are to be expected in coming years compared to the previous decade.